All right, number 17. Consider 4 sealed rigid containers with the following volumes: 50 milliliters, 100 milliliters, 250 milliliters, and 500 milliliters. If each of these contains 0.25 moles of helium gas at standard temperature, which container would have the greatest pressure? Okay? This actually is a conceptual problem. You don't even really have to do any math on this. You need to understand what is changing and what is staying the same. Okay, so we know that they all contain the same number of moles, so we know that that is constant, and we know that standard temperature, that means temperature is constant. So really what we're looking at is we're looking at volume and pressure. Okay, so we're looking at volume changing and pressure changing. So the relationship between volume and pressure is Boyle's law. All right, and Boyle's law, basically, remember it's the one that is inverse. As volume increases, pressure decreases, okay, or vice versa. And remember the equation for this is P1 V1 equals P2 V2. Okay, now we don't really need the equation in this problem. All we need really is this relationship right here. As volume increases, pressure decreases. Okay, or the other way to say this is to say as volume decreases, pressure increases. Okay, both of these are important because this question asks which one will have the greatest pressure. Okay, well, the greatest pressure means that it has to have the least volume. All right, so out of all of these volumes, we have 50, 100, 250, 500. If we were to put this in order, then when we go from 50 milliliters up to 500 milliliters, our pressure is going to go down because our volume is going up. So the answer to this question, very simply, is that the volume of 50 milliliters will have the greatest pressure because it has the smallest volume. And that is very simply just the Boyle's law relationship. And that is the answer to question number 17.